We're waiting on beta. Now that she's here, we can start our day. This will be our last day at chapter 4. I don't foresee a need to do more. We've been working on graphing and slope. And the equation for slope, we've done it a couple times, is m equals y2 minus y1 over x2 minus x1. And we have looked at y equals mx plus b form for an equation. We did a bunch with that. That's the slope intercept form. I don't know that we've done the other version here. If we clear fractions here, by multiplying both sides by x2 minus x1, we get, I'm going to put the y's on the left, y2 minus y1 equals m times x2 minus x1. And if you, at this point, dump this 2 subscript, we get y minus y1 equals m times x minus x1. This is called the point slope form. To use it, you need, it's black off, it's black, blue. To use it, you need the slope. And a point. x1 comma y1. We're going to retire that blue pen. Grab another one. Ready to give it a gander? Do some points and some slopes. And do some equations. Do anyone need to have longer? Okay. All right, so if we got m equals -2/5, and we've got the point 5 comma -3. I'll rewrite the equation on this page so we can see it again. This is our x1 and this is our y1. So we're going to plug them in. Y1 is -3. M is -2 over 5. And x1 is 5. The minus and negative becomes plus. And here we'll distribute. We have -2/5 times the x and -2/5 times -5. And I'm going to write that -5 is -5/1. And the two negatives cancel each other out right here. They make positive. And the 5's cancel. So I have y plus 3 equals -2/5 x plus 2 right now. And we'll subtract 3 from both sides to get y by itself. It's a little bit easier to graph that way. My oversized y. Looks like I'm a kindergartner. Let me give you guys one to try. M equals 3, and we're going to do the point 1, -2. You want to write it and end up having it as y equals something. Everyone ready? One y1 y minus -2 equals 3 times x minus 1. The negative minus negative 2 becomes plus 2. When we distribute, we have 3x minus 3. And subtract 2, and you get y equals 3x minus 5. Ready for more? Okay. You guys want to know what another one like that, or do another topic? Another topic? Does anyone else want? Does anyone want it? All right. We will go on. So sometimes we have 2 points. Let's say we have 2, negative 3, and 5, comma 4. And we can find the equation from just that. Now, they might, when you're doing the homework or the quiz, it might just plot the points and say, go from here, find the equation of the line. And if that happens, like, same thing though, I want you to be able to it might go, okay, there's a point here, point A and point B. And it might even tell you what the numbers are. It might say 5, comma 4, or you might have to actually count the lines and see what it is. The way we go about tackling this is find the slope first. And then 2, use either point slope or slope intercept. Now, slope intercept, this one is better if one of your points is the y-intercept. Otherwise, I don't really think it's better. I think it confuses students more often than not. So we're going to use m equals y2 minus y1 over x2 minus x1. I'll call point A 1 and point B 2. So point number 2 is the thing that comes first. The y is the 4 and the 5 is the x. And then in this one, we've got -3 and 2. The slope here is 7/3. Now, at this point, if you have a denominator like we do here, see if one of the points has an x value that's a multiple of the denominator. And use it if it does. We don't have that here, though. The denominator is 3, and we've got 2 and 5. And the reason why I recommend it is for the same reason we had right here. Distributing the 5 canceled it out, and we didn't have any fractions. Because the 5 was a multiple of the 5 in the denominator. If it doesn't, then you got some fraction work, and that's what we're going to be stuck with. So we're stuck with some fraction work. We can pick either point to be our x1, y1. I mean, I labeled one, the 2 and the -3, but we don't need those as it. I'll use them though. They got small numbers. 2 goes here and -3 goes here. So we have y plus 3. If I distribute this, I have 7/3x minus, we've got 7/3 times 2, 2/1. So 14/3. Which isn't a problem right now until we try to subtract 3. If I try to subtract 3 as is, it doesn't work. We need a common denominator. So I'm going to take the net -3 and I'm going to multiply it by 3/3 so that I get a common denominator. I get -9/3. That's what I'm going to subtract here instead of the 3. We do that, we're left with y equals 7/3x minus 23/3. And that's as clean as it gets. It's ugly. I just picked 2 points out of that thin air, and so it wasn't all that great. You guys want to try one like that on your own? Sounds like a yes. Need it up there longer? There we go. Okay. Here you go. Let's give you 1, 3, and -1, -9. No, let's make it -6. You guys get it done? Let's take a look what we got. All right, so what point did you guys use for, someone help me here? Pick a point for point one. If you say which point you picked, then you'll see the work done the way you did it.
What do you mean by point one? Like what you put on top and then
Well, we've got y2 minus y1 over x2 minus x1. Which one is point two and which one is point one?
Oh.
They go together, they gotta put them in the right order.
for point one, I did -3, -1. Well, wait, I don't know what you're,
So you use this one. That was your point one, and you did point two.
yeah,
So you would have, it looks like -3 and -1, I mean, it's really -3 and -1.
yeah.
Here we've got -6 and -1. So we got -9 over -2. Ugh. That's ugly. And then what point did you plug in here?
Y-3. And then x-1.
Redistribute. That's positive 9/2. And if we want to add 3 to both sides, we need to get a common denominator. So we can add 6 over 2 rather than that +3. And we get y equals -9 over 2x plus 15 over 2. All right, you guys ready for a word problem? Nope, I see a couple of still writing. Everyone good? All right, so we got a scenario. Marie Callender's spends $3,500 on wages, rent, and utilities. You know, all the good stuff to keep a business going. That's just this is called overhead. You're paying for the building. Then it costs them $5 per pie to make. This is probably higher than it actually is. But since I don't know what it costs them to make a pie, I just came up with my own number. including the overhead. How much does it cost for them to make 1,750 pies? All right, so let's kind of reason this out. If we got one pie, the cost is $5 times that one pie plus the $3,500. That's going to give us $3,505. How much was two pies? At $5 a pie, and they make two pies. And they still have the overhead. 5 times 2 is $10, and $10 plus 3,500 is 3,510. If I had 3 pies, $5 times 3 pies plus $3,500. $5 times 3 is $15 plus the 3,500 is 3,515. Now there's a pattern here, right? The cost is $5 per pie. So if I don't know how many pies there is, maybe I could say times X pies. Plus 3,500. That should be the cost. That gives us the total cost. I'll use C for cost. I mean, I think X is not a very good letter for the pies. Maybe we should use P for pies. So if they need an equation, we've just come up with an equation. And they wanted 1,750 pies. So we can plug that in for P. So this is 8,750 plus 3,500. $12,250. They usually have a problem in there. For you to do in the sport stuff, so. And I think we've kind of beat this horse dead. So we'll call that a wrap for that session. How's that sound?